Hello and welcome to another lecture on basic electrical engineering. Myself, Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Degree Engineering College, Electrical Engineering Department. So today we will discuss about AC circuits, the introduction to AC, how AC is formed. So let us. The name that is called AC is known as alternating current. The name suggests that it is alternating in nature. AC is alternating in nature. Alternating means from the name it is seen that there is a change of direction of the current or the voltage or the electrical quantity. That is why it is called AC. So let us take how AC is formed. Now let us take steady magnets, that is north and south pole, which are generally responsible for producing the steady magnetic field. The magnetic field direction is always from north to south. It is responsible for generating the steady magnetic field from north to south. Let us conductor is placed, a conductor that is placed between north pole and south pole. Let us a conductor is placed between the north pole and the south pole, which in turns connected to a load, which in turns connected to a load. Let us the conductor is A, B, C, D. Now, when the conductor starts rotating, it will gradually cut the flux. So there is a rate of change in flux. According to the Faraday's law of electromagnetic induction, a voltage that will be generated in the coil is directly proportional to the rate of change in flux. That is ddt of phi, flux that is generated, steady north and south pole flux. This flux will cause a current to flow through the ABCD and also to the load. So let us, for the first instant, the current that is flowing from the load to the coil, it is coming back to the load in order to blow the bulb, in order to blow the bulb. So this is the direction of the current that is seen, that is from C to to A to B to D, and through the load. The direction of the current that is given, it is from C to A to B, A to B, B to D, and D to load and load to C. That is why a cycle is, that is why a cycle for the load is completed. Let take another example is that when I have told that the conductor is in rotating condition. Say after the 180-degree rotation of the conductor, the positions of the conductors will be changed. So it is again a steady north and south pole that is developed. The position of the conductor that is totally changed. So let us take the conductor here and it is connected to the load. Connected to the load. Now, as the conductor rotates, the position will be changed. Now, this position will be B. The conductor is rotating in that direction. So the rotation of the conductor is like that. If the conductor doesn't rotate, it will not able to generate the rotation of the conductor will in this direction. It will not able to cut the flux and it will not able to generate the voltage according to the Faraday's law of electromagnetic induction. So as the conductor rotates, the position, the coil now changes after 180-degree rotation. So let now direction of the current flow to the load will remain same in order to blow the bulb. So it is clearly seen that all the direction of the current flow is totally changing, but throughout the load, the current flow remain unique, maintain its unique or the same direction to the load in order to blow the load. So now the direction of the current flow is, now previously it was from C to A, now it was from A to C. So say it is from A to C to load to E to B to A. So it is there from, previously it was from, you can write this in that way, you can write that particular thing in that way so that it is easy to understand that the direction of the current flow will be, if I start from the left hand side, it is from B to D to load to C to A, and it is routed back to B. Yes, and is routed back to B. So it is clearly that here it is from A to C and here it is from C to A, or it is from D to B, it is from B to D. So there is a change of direction of the current flow. Means the conception of the alternative in nature is come into the play. So this is the general conception of producing an alternating current. So now we'll see the representation of sinusoidal waveform. How a sinusoidal wave is generated. How a sinusoidal wave is generated. So in order to generate a sinusoidal wave, let us start with. So that it can be easily understood by you. Okay. So each of that particular thing is our conductor. Each of the particular thing is our conductor. There is a position of the conductor. Is the position of the conductor. Easily understood that those are the positions of conductors. Means the conductor is in rotating conditions. Those are conductors. And it is in rotating conditions. Say the give a name of those conductors. They are giving a name. So the name is I'm giving this one A position. This is B position. C, this is C. This is D. This is E. This is A. This is G. Means conductor is rotating. And rotating, this is H, rotating in that direction. First position is A, followed by H, then G, then F, then E, then D, then C, then B, and again this number is A position. So I am extrapolating that particular line. I am extrapolating that particular lines. So we can easily see the formation of sine wave. In order to obtain the formation of the sine wave, higher sine wave, and the alternating nature of the wave is generated. The pictorial view of generation of sine wave. Okay. So let us take some points. That is the image, reflection of the image. If this is C point, from the this is the origin and this C point, so this is the C point. That is the C point. And again it is rotating in that direction. So this is the B point. Same distance will maintain and this is the reflection of the B point. This is the reflection of the A point. the reflection of the A point, and it is H. So this is the same equivalent distance. This is the reflection of the H point, and again it is coming on to the G. So this is the reflection of the G point. Followed by that, this is the reflection of the F point. The reflection of the E point. This is the reflection of the D point by extrapolating. This is the reflection of the D point, or say the mirror image, and this is the reflection of the C point. Again the C point. So if I draw the graph, if I draw the graph, draw those points, joining those points, there is a generation of sine curve is there. There is a generation of, I draw those points, it will generate a sine curve. This is the way I can say that is the generation of sine curve. This is the way we can able to generate the pictorial representation of what we have told, that is the sine curve. And it is clearly seen that if this is taken as an axis, so the graph of nature will be, if this is taken as an axis, so the nature of the graph is this, means it crosses the axis. If it is crosses the axis, then it will be considered as an alternating in nature. And this is the pictorial view of the representation of the sine curve when a conductor is started rotating. And this is generally a repeating. It will cause a repeat. So say this is 2 0 to pi, pi to 2 pi, pi to 3 pi, 3 pi to 4 pi, say. So it is seen that from the particular graph, that it will again, the C point is again starting to repeating. Means it will again start from the C point. It will again start from the C point and it will continue repeating that way, C, B, A. So as it is again starting from the C point, so means this one portion, that is pi to 2 pi, this portion is generally known as cycle. Is known as one cycle. See, one cycle. This is known as one cycle. And number of cycles, that is cycles per second, will give up the value of frequency. It is known as frequency. It is called the cycle per second. It is known as frequency. Say in India, our standard frequency is 50 hertz. HZ is the unit of the frequency called hertz. So it means standard frequency in India. So it means it is 50 cycles per second. That is the general known of an frequency. Our frequency is calculated and this is called the cycle, and this cycle is repeated. So cycle is repeated after the value of, say, this is time t equal to 2 pi. Okay, so this is the voltage magnitude. Alternating in nature means it have to cause the zero axis, this axis. So that is after a certain time period or the time interval or the time value, say the time interval, the graph is again repeating in nature means it is again starting from the say and it will repeat. So this is the time or the time interval after which the graph is repeated is called the time period. So this is the total known as time period. So time period here T has been denoted as here for the this sine curve it will be 2 pi time period. Means after 2 pi value 0 to 2 pi that is the time period. So total is the 2 pi. So 0 to time period 2 pi that is the 2 pi time period. It will after 2 pi time period it will start repeating. So this is known as time period. Time period. So how frequency is related with the time period? Time period means the time interval after the graph or the cycle start repeating it is known as time period. And now the frequency is repeating. Frequency is related to the time period. Is frequency is 1 by time period t. Is the general relationship between the frequency and the time period. So here the pictorial view of the sine curve followed by the conception of the frequency. So conception of cycles per second is known as frequency, followed by the time period is seen here. And relationship of the frequency with time period is also shown here. Now we will know how the mathematical expression of an AC can be calculated. How this graph is called a AC graph. Mathematical expression of that particular graph. So let us take a graph. Okay, so let us take a graph. So this value will be 1 and this value will be the we know for the sine graph this value will be minus 1 and time period is from 0 to pi to 2 pi. So we have to concentrate on the area under the graph. So how we can able to find the area under the graph? So let us area means that this portion. So what is the area of this portion? So this is so the area of this portion is say that it is z OAC portion or sorry 0 OAC portion. So what is the area of OAC portion is OAC portion is that is 1 in height and total time that is the time gap times pi minus 0 that is pi. Now CDE is a so what is the area of that particular CDE portion? This one into time interval. So area of CDE portion is the height that is minus 1 into 2 pi minus pi that is the times 10 2 pi minus y that is the minus 1. So what is the total area? Total area can be calculated for a particular time period 2 pi. Total area for a time period 2 pi will be the area of OAC that is pi plus the area of CDA that is minus pi. So the total area under the graph is 0. If the total area under the graph is 0 for a particular time period, what was the time period t? That is the 2 pi. For particular time period, for a particular time period, if the total area under a graph is zero, then it is called the AC graph. This is a mathematical representation of an AC. AC graph means for a particular time period, if the total area under the graph is zero or under the graph is zero, it is known as AC graph. So today we have learned about what is AC and how an AC is generated or how AC is formed and what is the pictorial representation of the sinusoidal graph and along with the sinusoidal waveform and along with the pictorial representation of the sinusoidal waveform and along with the mathematical expression how we can say that this graph is an AC1. The area under the graph is zero for a particular time period is called the AC1.